Great. Hi, everyone. I am presenting live from Seattle, and I can't see the room as this is my first time using this system. So we will work through it. Thank you so much for the time and being here. So as was mentioned, rather than what I've done in the past, cover sort of what we're doing on the uh, product side, which I'll still get into. But this time I did want to talk about what we are seeing with Azure Confidential Computing, especially with all the activity and progress happening in the sovereign cloud space. So with that, let's get started. So first thing I'll cover is what are we seeing as part of the sovereignty requirements? What do we think about confidential computing at Microsoft? And then talk a little bit about our roadmap with Azure Confidential Computing. So first, let's get started. From a sovereignty perspective, we have been in this space for a while and we have been working with customers and we have learned a lot. And that's what we wanted to share. So essentially, when it comes to the sovereignty space, we are seeing every few days new regulations emerge, shaping how we use AI, how do we manage data, how do we secure our digital services. In fact, the last time we checked, there were over 1,000 global policy initiatives across 69 countries and 100 nations enforcing these sort of privacy laws. And this isn't just a technology challenge, it's a trust challenge. This is sort of why digital sovereignty matters. It gives organizations and companies and sovereign nations the ability to innovate on their own terms while maintaining compliance, control, and security. So, before we start off, I think it's important to mention what is digital sovereignty. At its very core, digital sovereignty is the capability to participate in this digital economy securely, independently, and with self determined controls. So we need to be connected and work with sort of these international organizations, international customers, and international providers. And our approach to the digital sovereignty is pretty straightforward. Digital sovereignty should be foundational to our cloud and services. It's delivered through a well governed combination of technical, contractual, and operational controls. And because every workload and every organization has different levels of sensitivity and criticality, sovereign requirements themselves are adaptable to the needs of each workload that we see. So we have been active in this space for a while, uh, over the last 10 odd years. So you see that over a decade, we've made investments in privacy, security, compliance, all the way from GDPR to the German sovereign cloud to launching the Microsoft Cloud for Sovereignty. And as was announced by Satya, our CEO, back in June, Microsoft Sovereign Cloud is the next step in this journey. And now I will drain each of these compliance offerings one by one. No, but we do have a bunch of compliance offerings that are super critical to organizations using workloads in production. These sort of capabilities are critical for enterprise workloads. So when we now talk about Microsoft Sovereign Cloud, we are building on our existing experience of delivering sovereign capabilities across our cloud. So this spans both the public cloud and the private infrastructure. So the customers can choose what is the right balance of control, compliance, and capability. So this solution that we are talking about here is designed to enable organizations to have comprehensive solutions across sovereign public cloud and to cater to specialized needs like what we see in the sovereign private cloud and the sovereign partner system. So when we talk about the Microsoft Sovereign Cloud, it is built to support the full spectrum of these needs, whether those are regulatory environment requirements so that customers can have confidence in the data and operations to meet local and national compliance standards, or whether they are sovereign data AI processing requirements, or the no cloud operator access, meaning that customers retain authority, their data and workloads stay protected with safeguards against unauthorized access, even from Microsoft. Our data residency plays a big role here. And finally, obviously, business continuity to ensure that mission critical workloads can continue securely, even in the event of natural or as we are seeing today, the natural geopolitical situations around the world. So when we dig into sort of the no cloud operator access, what does that mean? What we see is customers want to protect their sensitive data, not just from hackers, but from themselves or even the cloud provider. So they can do this through a layered approach. Obviously, we want in the industry, it is encrypting data and rest and in transit is a standard already. And then with confidential computing, customers can keep their data encrypted from outsiders while it's being processed. With confidential computing available and customer managed keys themselves play a big role in this, especially when our customers use our managed HSM offering, which is itself a confidential key management solution that we built. The data remains private, governed, and fully under customer control, even in the most sensitive and regulated environments. So when we talk about digital sovereignty, this can mean different things to different people with needs that vary, even between workloads. It's not a one size fit all, and it's splits into operational controls and data controls. So in operational controls, and as an example, we have advanced data residency needs for Microsoft 365. And for data controls, we have a bunch of offerings around Azure Key Vault Premium, Azure Key Vault Managed HSM, sovereign landing zones, and of course, Azure Confidential Computing. So before I start digging into the confidential computing side, one of the most important elements that we hear from customers is keys, customer managed keys, and specifically their requirements from the Azure Key Vault Managed HSM offering that we have, where customers' keys are secured and highly available in these single tenant HSMs, where strict sovereignty controls are enforced via confidential enclaves. So this with managed HSM, we have centralized key management capabilities, which manage keys across the organization and integrates with the various Microsoft services that we have, ranging from Microsoft 365 to Azure Storage to Cosmos DB. And all of this is integrated with Azure Policy to allow automated key management at scale. This is sort of what we are hearing from our customers. So as we dig in deeper into the stack, we have put sovereign controls at every layer of the stack, whether that's our data center DCSCM, secure control module, the integrated HSM, one of the on-node FIPS 140-3 compliant HSM cache that we recently announced that will ship with every node that we will have. Of course, the work that we've done with Azure Boost, that we are extending more, and I'll talk about more about how confidentiality integrates with it. And of course, confidential computing becomes a key part of the solution here for how we use hardware-based EEs to protect these sovereign workloads. So when we have been working with the industry, here are the four sort of key partners that we have, ranging from G42 in the UAE, Korea Telecom in South Korea, Leonardo and Proximus as well in the EU, that we've been working for a while. And based on this, I think what we have decided to do here is share what are the sort of sovereign workload types that we are seeing actively employed and deployed in Azure Confidential Computing. And there is a range, right? Eventually, all workloads will operate this way. But initially, what we see is, high sensitivity business applications, whether those are line of business applications requiring strict data sovereignty, operator isolation. This includes internally developed apps and apps that are, either third-party software deployed via lift and shift capabilities. We've also seen core infrastructure components, what we call the foundation layer, whether those are domain controllers running inside CDMs or identity services running inside, confidential computing. These are the foundational pieces that are critical to the organization, and we see them starting to run in confidential computing. The next layer that we expect to see a lot more on is the data and analytics workloads, whether those are large-scale analytics running on Kubernetes worker nodes, or something that is more sort of a compute-intensive pipeline requiring high I/O ops between sort of the components running in the compute stack. And further down the line, we see a lot of interest in sort of these confidential databases and stateful services, uh, where we start seeing the next layer of maturity in these workloads, where, as I mentioned earlier, the line of business applications start becoming real, with real sort of workloads being deployed. I won't go through these two videos, but I've linked them here. These are two sort of our closest partners with G42 and Korea Telecom. And we've learned a lot with them. So what I showed you on the previous slide was some of the learnings after working not just with them, but also many other customers in this space. Let me go ahead here. So with that, I'm going to now shift into, okay, this is what I just showed you was what we are seeing and learning from sovereign workloads around the world, right? Whether that's at EU, whether that's in the Middle East, whether that's in APAC, or even in the United States. We're seeing similar sort of requirements, similar sort of capabilities. And one of the key important elements that comes through is mission critical software that needs to run with mission critical workload resiliency requirements. So when we look at sort of confidential computing in Microsoft, we've done a bunch of effort with our Secure Futures initiative. This is something that we've been on for a couple of years. It's basically a process of continuous improvement, whether that's protecting identities and secrets, isolating our production systems, our networks, our engineering systems. We do a ton of work on monitoring and detecting threats. And this is sort of the goal, is to get secure by design, secure by default, ensure we have secure operations. And one of the key sort of capabilities here is when we talk about protecting our identities and secrets, the first element in this is running on confidential computing. So we announced this a while back now, in 2024, but at the end of 2025, we have 100% migrated our identity stack onto confidential managed HSM that I talked about before, and the confidential computing stack. So this helps our customers get more assurance that the identity stack that they're using is secure and protected from the cloud operator. Now, this is just the identity stack. So when we think beyond the identity stack, we have, sorry about that. We have a concept of the Azure PCB, which is what is in the Azure Trusted Computing Base. So in the Azure Trusted Computing Base, the first element that comes through is we have our data center and hardware capabilities that we deploy, in our data centers. And on top of that, we run our foundational PCB elements, the foundational trusted computing base. This is our compute hosting, our deployments, our operational management, our private key infrastructure, secret management, inventory control, pretty much everything that is foundational to running the Azure cloud. So we are, slowly moving, and in many cases, move quite a lot of them over to confidential computing. The current default is trusted launch. The future default will be confidential VM. And then, as we know, containers provide a much tighter TCP than a VM. The future standard would be confidential containers, given that you can attest every layer of the container stack. And on top of that is sort of where we build our VMs, containers, our products and services, our customer workloads run on top of it. So we see sort of this progression happening gradually over time as the stack matures, and we see more of these workloads running real mission critical software. So now let's shift gears. I talked about what we are seeing in the sovereignty space, how we are looking at confidential computing inside Microsoft. Now let's talk about, okay, what do we see ahead? What's going on right now in the confidential computing space from Microsoft. So first, we have the AMD V6 confidential VMs on AMD SEV SMP that we have GA'd in 19 public regions. I think it's 40 availability zones. And we also GA'd them in the Azure government region. And over time, we will be GAing in additional regions. The regions are listed down below. And in terms of feature capabilities, we have 25% performance boost over the last generation. We have support for key capabilities such as online key rotation, backup, restore, migrate, all of those fundamental capabilities that make a confidential VM a great VM. All of those capabilities are also coming online. So things like Kubernetes support is already there for a while, but this sort of stack is running our identity stack that I mentioned earlier. A lot of our stack, our foundational TCB runs on this, as well as many of the customer workloads that I talked about in the sovereign space, not just the sovereign space, but overall regulated environment that we see. And very recently, I would say, as recently as a couple of weeks ago, I suppose, we announced the Intel TDX V6 confidential VM GA, general availability. This one has OpenHCL firmware, which is open source now, to improve the transparency that we can provide the customers. And right now, at GA, we have the accelerated NVMe local storage, the key guard support, up to 128 vCPUs and 512 gig memories. But even post GA, we will be releasing additional features addressing performance gaps in the offering, and then regional availability will also increase sort of over time. So we've started GAing in a couple of regions, and more will come online over time as we run through our secure deployment processes. So the next thing I did want to talk about is sort of the innovative work that we're doing in our hardware offload capabilities. So some of you may know about Azure Boost. It's about infrastructure acceleration. So typically on the left side, you'll see traditional infrastructure where there's a hardware, and then you have the host operating system, you have KVM or Windows hypervisor running the stack, which on top of it runs the customer workloads. So when you shift to the right side is when you move to an offloaded infrastructure environment where Azure Boost is now doing the accelerated offload. It's running the agents, it's running the host capabilities and storage networking, etc. And what you have is that the node is now available, 100% available for the customer workloads. So you have the VMs and containers running in the node, and there's an IO layer. And in addition to sort of the hardware acceleration, there is a security and resource boundary, isolation boundary that gets created because you have capabilities like Boost. So with Azure Boost, we have a bunch of sort of capabilities around 20 gigabits per second throughput, 1 million disk IOPS, 400 gigs networking. But the thing that I want to get your focus on is the work that we announced as part of ABCD, which is Azure Boost Confidential Device, which is using the TDISP standard for encrypted IO. This is something that we announced recently, and we are actively working on it. But this will now start eliminating the gaps between confidential and non-confidential environments, because this is sort of what customers are asking for. They want a no asterisk confidential computing environment. So when you compare it side by side, without confidential device offload, as we know for a long time, we've had to do bounce buffering, which adds additional CPU cycles to the customer workloads, which is not ideal. So the customer has to pay extra for getting the sort of IO that they need, right? But with ABCD or with device offload, you now have, say, a confidential virtual machine directly connected to the confidential device, the Boost confidential device, through an ID encrypted PCIe link direct chain. So, the benefit of it obviously is it enables confidential offloads, but it reduces or decreases the CPU usage, enabling these accelerated data transfers between the CVMs and directly to the devices. This will become critical for high IO throughput need workloads, for AI-bound workloads, running a large LLMs. But with this capability, we start removing sort of the final asterisks around making confidential computing essentially fully capable to its non-CC counterparts. This is not a comprehensive list, but you may have seen this list before. But the way we think about our capabilities is we first sort of been working at the infra layer with our partners in, AMD, Intel, NVIDIA, ARM64, etc., to start bringing in the capabilities in the silicon. We build virtual machines and containers on top of it, uh, integrating with Kubernetes or serverless in ACI, using a virtual node if there's a hook needed with Kubernetes. But those are the foundational elements. And on top of that, we start adding sort of the services. And this is not a comprehensive list, as I mentioned, but this is around things like, we have Azure Batch capabilities available. We have Azure Data Explorer. One of our most popular first-party services is confidential Azure virtual desktop, as an example. And we've done sort of work on the confidential inferencing with Azure OpenAI. I already mentioned the identity services, and there's a bunch of sort of services that inside Microsoft we call it. If you're in field and sales, you say drink your own champagne, or if you're in engineering, we say eat your own dog food. So we have been spending a bunch of effort on improving the security story of our internal first-party workloads, getting them mission critical, getting them ready for sort of this higher secure environment. So with that, let me kind of get to the closing elements. So when we talk about confidential cloud, what we mean is, basically around these four vectors. One, data is in fully control of the customer, whether that's at rest, in transit, or in use. The cloud provider, which in this case is Azure, or even the customer themselves, are outside the trusted computing base. The code running in the cloud is protected. It's not just trust, it's also verified by the customer. And activity history is immutable and auditable. So thank you so much for your time. Apologies for the earlier technical difficulties.